Hi, everyone. My name is
My
David,
name is Abdul.
and we're going to be talking about what we did for our Build.com challenge. First, we're going to talk about the problem, then we're going to talk about our intuition, and then we're going to talk about how we learned heuristics. So we're going to skip setting up the problem because we've been running out of time. But given this social network of graphs of edges, we really had some problems. There were different types of data that we had to deal with: categorical data, relational data. We had no test labels, so we had to conduct our own training pipeline, and we have no experience in graphical models.
This is the first graph. We have a sample of 1,000 nodes randomly sampled in the graph. As you can see, it's already a big graph, and it's already a subset of the graph. This is the full graph, more than 20,000 nodes. It was really complicated to pre-process and learn the model on. The training pipeline. So we needed a way to confirm that our learning was sound. So we split the data into training and test splits, 90 and 10% split. The 10% was split into positive labels and negative labels to be able to test for both types of labels.
So first we started off with Descartes similarity. We wanted to see if a page, we hypothesized that a page is connected to another if they have many overlapping connections. We swept over initial threshold, and any nodes that were with a similarity index higher than that threshold were predicted an edge that was 58% accuracy. Next, we looked towards embedding-based approaches. We wanted to create an embedding space where close by nodes are similar and likely have an edge. We initialize that randomly. We move those embeddings closer together by some factor, and we use a distance threshold by sweeping through. So that was 50% accuracy. Next, we use node to vec to get our embeddings, which was a lot better at 61%, but we likely can't learn much, which motivated us to
use the learn heuristic method, which we used a graph neural network for that. We used a 2-layer graph neural network using Stanford's scientist Graph Sage model. And we incorporated features from the one-hot encoding as well as the node classification, and used the dot product metric to propagate the error backwards and iteratively improve the prediction of the model. And for that, we got an 88% accuracy rate using the AUC, area under curve metric, after using the graph neural network model.
So for our next step, we definitely want to do more hyperparameter tuning for each of the models. We'd want to do more visualizations for the Graph Sage embeddings because we haven't done that. And we'd also like to potentially use BERT embeddings if we have the original sentences. But thank you so much for hosting this challenge. We had a lot of fun.
Stop recording.